Welcome back to my channel. In this video, we will see some tutorial problems in operational amplifier circuits. Determine the voltage gain for the operational amplifier shown in figure. Circuit is given. You have to find the voltage gain for this circuit. In this circuit, input is applied at the non-inverting terminal and inverting terminal is grounded. So this operational amplifier circuit is a non-inverting amplifier. And here the feedback resistor is 10 kilo ohm and the resistor which is connected to the inverting terminal is 2 kilo ohm and our input is 5 volt. We know the formula to calculate the voltage gain of the non-inverting amplifier, that is V0 by Vi, which is voltage gain, output voltage divided by input voltage, that is equal to 1 plus Rf by R1. Rf is the feedback resistor and R1 is the resistor which is connected to the inverting terminal of the operational amplifier. We know the values of Rf and R1 which is given in the problem. So if you are substituting these two values, you get the voltage gain of this circuit. So Rf is 10 kilo ohm and R1 is 2 kilo ohm. Then you get 6. 10 divided by 2, that is 5. Then 5 plus 1, 6. So the voltage gain is 6. Next problem. For the non-inverting amplifier shown in figure, determine AB, that is voltage gain, V0, output voltage, IL, that is load current, and I0, that is output current. This is circuit given in the problem. So for this circuit, you have to find the voltage gain, output voltage, load current, and output current. And already it is mentioned that it is a non-inverting amplifier because input is applied at non-inverting terminal and the inverting terminal is grounded. So it is a non-inverting terminal. And input voltage is 0.6 volt. Feedback resistor is 20 kilo ohm. Input resistor that is connected to the inverting terminal is 10 kilo ohm and the load resistor is 2 kilo ohm. It's all given in the problem. Okay. And for non-inverting amplifier, we know the gain formula. AB is equal to V0 by Vi, that is equal to 1 plus Rf by R1. So V0 output voltage, Vi is the input voltage. The ratio between that output voltage and input voltage is equal to voltage gain. Okay. So let us start from AB, voltage gain. So voltage gain, we know the formula. Here Rf value is 20 kilo ohm, R1 value is 10 kilo ohm. Substitute that values here. 20 by 10, that is 2. 2 plus 1, 3. So the voltage gain is 3. Here we know all the values. So by simply substituting the values, you get the voltage gain. And the voltage gain value is 3. So next one is V0. V0, we are going to calculate this V0 from this formula. That is, your voltage gain V0 by Vi is equal to 3. We know the value of voltage gain and the voltage gain is equal to V0 by Vi. Right? So V0 by Vi, we know the value of voltage gain. Here Vi, that is the input voltage applied to the operational amplifier, that is 0.6 volt. So we know Vi and AB. So from this value, you can find V0. V0 is equal to 3 multiplied with the input voltage Vi. Input voltage is 0.6, so you get 1.8 volt. So output voltage is 1.8 volt. Next one is load current. So here, load current, that is current through the load resistor RL. IL is the current through the load resistor RL. Here the potential is V0 and V0 is the potential across this load resistor RL. So by Ohm's law, you can write this V0 as V0 is equal to IL multiplied with RL because V is equal to IR. Here the current is IL and the resistance value is RL. So you can write V0 is equal to IL into RL. Okay. Here V0 we know that is already calculated as 1.8 volt, and RL that is also given in the problem 2 kilo. So by substituting these two values we get V0. IL that is equal to V0 divided by RL. V0 is 1.8, RL is 2 kilo. So 1.8 divided by 2 is 0.9, and 1 by 10 power 3 is 10 power minus 3. So you get 0.9 into 10 power minus 3 amperes, or simply you can write this as 0.9 millivolts. So this one I0. I0 is the output current here. It is the output current. So to calculate this output current, we have to apply KCL at this node output. Here, this is the feedback current. So the feedback current direction is this one. This is load current, and this one is output current. So at this node, entering current is I0 and leaving current is IL and IF. So if you are writing KCL at this node, you get I0 is equal to IL plus IF. IL already we have calculated, that is 0.9 milliamps. IF, we don't know the value of IF. So here you have to calculate what is IF first. So IL is 0.9 milliamps. Then IF. IF is the current through the feedback resistor, right? So I can be calculated from Ohm's law. I is equal to V by R. So the potential across this resistor RF is, here the potential is V0 and here the potential is VI2, right? So the potential drop across this resistor is V0 minus VI2. So that is the potential drop across the resistor RF. Then divided by the corresponding resistance value, that is 20 kilo. So this is the formula to calculate IF. So IF is equal to voltage drop across this resistor RF, that is V0 minus VI2, divided by the corresponding resistance value is RF. V0, we know the value 1.8 volt. What is VI2? VI2 is the potential at this node. Here it is a negative feedback operational amplifier. So in negative feedback operational amplifier, by virtual short concept, the two nodes are at equal potential. So you can take this VI2 as 0.6 because the potential at this point is 0.6 volt. Substitute the values here. V0 is 1.8, VI2 is 0.6 divided by RF value is 20 kilo ohm, so 20 into 10 power 3. 1.8 minus 0.6 is 1.2. 1.2 divided by 20 is 0.06. Okay, so you get 0.06 into 10 power minus 3 amperes or 0.06 milliamps. This is IF. So we know IL and IF. So from this you can calculate I0. I0 is equal to IL plus IF, that is 0.9 milliamps plus 0.06 milliamps, that is 0.96 milliamps. Thank you for watching.